Hello friends, my name is Shriprakash Singh and you're watching BIandDataScience.com. This is the third video in 5-part series that helps you learn and master programming in Python. In today's video, we are going to talk everything you need to know about functions in Python. We'll learn what functions are, when to use them, and how to write functions from scratch all the way to proficient level. Don't go anywhere. I'll be back after a very short intro. So functions are nothing but a piece of code that are chunked together to perform a specific task, and we can call them and run them any number of times. To understand, let's understand a basic example here. Suppose you want to build a game of chess in Python. So what you need to do is every time there would be two players, right? Then there will be a board of chess which has 64 squares, and then you have 16 pieces for each of the player. Like you have the knight, the rook, bishop, king, and queen, right? So, and pawns. So you have these different kind of pieces. They move following certain rules, and then each player takes a turn. Now think about how will you be building this whole game in Python. To build a game, lot of things happen in a repeated fashion. For example, one player moves, and then you have to make sure the move that player has moved is valid, and if the move is valid, then you start thinking of, okay, is there a check to the king? And if there is no check to the king, you start thinking what should be your best move, and then you make a move. And again, the second player has to validate whether the piece that you move is legit or not, and the other player will do the same thing. He will look at his vulnerability, like whether his king is under attack, and if there is a check. If not, he will think what pieces to move, right? So these are actions that are repeated in every iteration. So what is happening is I am following a certain set of instructions every time my turn comes, and same instructions are followed by the other user when his or her turn comes. So the idea was be, if you start writing all these instructions, then what will happen is you will write these instructions for player 1, then player 2 has to do the same instructions. If you write the same instructions for player 2 and again similar instructions for player 1, there is a lot of repetitions, right? You will be repeating the same piece of code again and again. And if you have to make a change in these codes, say you forgot something or you made an error, now you have to correct that error. So you have to go and correct error at all the places where you have written the same piece of code. Now, how easy your life would have been if you wrote these codes one time and you had some method of running that code whenever you needed. This is exactly what a function does. It lets you label a piece of code with a name, and whenever you call that particular name, the whole piece of code that is associated with that name will run. Coming back to our chess example, suppose when you are validating a move, suppose you have 10 lines of code that validates whether the move is legit or not. Now to validate the move, function needs some kind of input. It needs to know what was your starting position and what is your ending position, and then it will validate if the move from the start to end on that board for that particular turn is valid or not. The start position, the end position, the board, and the turn of the player, these are all called parameters because these are the inputs for the function. Every time you call the function, these information has to be supplied to the function to make sense of it, and then function can also return some information at the end. So there is a piece of code, you gave it a name. Every time you call that name, that piece of code will run, and to run that piece of code you might need some information. You give those informations, and after those pieces of code has run, you will get some out. This is called the return value. This is what the function is returning after doing all the calculations. For example, in your move validation function, the output can be true or false. If the move is valid, the function will return true. If the move is invalid, the function will return the value false. Now to summarize what a function is, we can say function is a logical block of code that is assigned with a name, can be called again and again using that name. It takes some parameters and provides some information called as the return value. Now let's see how this looks like in Python. Okay, now let's create a new file and we say the file is a Python file. Okay, now let's first take an example where we are going to do the same thing again and again. For example, say I want to print cube of 2, 3, 4 and 5. Okay, so what I can do, what I can write in Python is print, and I say first time I say cube, and I'm printing using a f string, which is a formatted string. I've talked about formatted string printing in both the part 1 and part 2 videos. So in the first video we learned about the fundamentals of programming, including variables, data types, operators, learn how to write basic control flow statements around sequential, conditional and looping. In another video I have walked how to download and install Python either from python.org or using anaconda.com, and I showed you how to install VS Code and run sample programs in Python. In the second video of the series, we built a simple calculator that would ask 2 inputs from user and do the operations based on the operations selected by user. We printed a table using for loop, and in the end we created our own version of REPL for the user calculator. So if you haven't watched the prior videos, I recommend go ahead and watch them. The links are in the description. They will give you conceptual clarity. So we say print formatted string cube of 2, 2 times 2. Okay. Suppose this is what we are printing. Now if you print this, what it will print? It will print cube of, okay, this is square, that's not a cube. So yeah, 2 times 2 times 2, right? So it will print cube of 2 is 8. Okay. Now say I wanted to do the same thing for 3. So I can go and I can copy and I can print the code here, and then I have to change here 3, here 3, here 3 and here 3. And same thing if I want to do for 4 and 5, I'll have to change 4, 4, 5, 5, 5, 5, right? Now let's go ahead and run this. Now see, it prints cube of 2 is 8, cube of 3 is 27, cube of 4 is 64 and cube of 5 is 25. Now you can see every time I have to write a cube of new number, I have to change here and 3 times here, right? What about if I could go and create a function that does this same thing, and I can call that function say 5 times. So for what I can do is, let's go and create a new file where we will now do the function. Again, it's a Python file. So we'll say here, let's create a function. Now to create a function in Python, you use the word def. So def is a keyword that is used to tell whether something is a function, just like int is a keyword to tell integer, right? So we have def. And let's call the name of the function as cube. So cube is my function name, and then cube will take an input, and that input would be whatever number you want. So I can say num is my input to the function. And just like after if, else, for, do, you use this semicolon, we will use the semicolon. Now you see Python indents. It means whatever I'm going to write here is part of def. So here now I can write print, same thing that we were printing there, cube of num is num times num times num. Okay. And this is it. This is what my function does. It takes a number and it prints the cube of number is this. Suppose this is my function. Now I can call this function just like we were writing the whole print. I don't have to now write the whole print. I can just say cube 2 cube 3, right? This is nothing but I'm calling the function. I'm saying, hey, whatever is my function cube, you do that same thing for input 2. Whatever you are doing, just do the same thing for input 3. You do the same thing for input 4. I say cube 4 and I say cube 5. Now if I go and run this program, see, we got the same output. We say the cube of, because when this function, when this line is running, it's running this whole thing. When this line is called, when cube 2 is called, it's going and it's printing the cube of 2 is 2 times 2 times 2. So you remember, whatever we were trying to do, this is happening inside the function when it's called first time. And then when I say cube 3, the function cube is called, 3 is passed in num, and it's printing cube of num, that is 3, is 3 times 3 times 3. So it's doing the same thing that we were doing in this line of the code. So now you can see, rather than typing all these lines so big, all I have to do is I have to call cube 2, 3, 4, 5. So this is a basic example of function where we are trying to write my print statement inside the function, and we are calling the function with different parameters. Now, whatever is input to function is called parameter or argument. A function can have, this is the beauty, like here, for example, in this parameter, if I don't pass anything, I can say by default the num is going to be, I can say num is going to be 2. This is called my default value. So I'm saying now I can call only cube. I may not give any value. So let's see what. So you see right now it's printing cube of 5 is 125. Below that it will again print cube of 2 is 8. See, it prints cube of 2 is 8. Why? Because when we don't pass anything inside cube, it assumes it has the value of 2. So by default, it gives you the cube of 2. Otherwise, it will give the cube of the number that you pass in the function as a parameter. What we learned is we use the def word to define the function. Then we use the function name followed by def. So we say def function name, and in parentheses, we specify all the parameters that we want. If we don't want any parameter, we can have it, we can leave it blank, right? So for example, we can go ahead and we can create here another function. I say new file, Python file, and here we can say def. Suppose here what I'm going to do is I'm not taking any parameter. I need to give it a name. Let's call it intro. Okay. And then in intro, what I'm going to do is I'm going to say first print hi, print my name is, say anything, my name is X, print what's your name, and we end it. Now when I go and I call say intro, let's run this. It says hi, my name is S, what's your name? So these 3 lines are written inside my function intro. Now, however, how many times I call intro, those same 3 lines will get printed. So 2 times intro will get 6 lines. You see here, this is the first call to intro, and this is the second call to intro. This is about basic information about function. They are logical group of code. They take an input. They may take an input. They may take a default input, and then they may return a value. Let's understand what are the benefits of using function. So we saw function reduces repetition, right? So this is the biggest use of function. So if you want to do the same thing again and again, for example, if you are building a simulation for a game, you want to do certain things again and again, all those repetitive tasks can be one function. So that is minimizes the duplication. It also improves the readability of the code. But second important thing what it does is it allows us to break down our big program into manageable pieces of code, right? So, for example, in the game of chess, like there were, say, six different steps. One, we have to validate the move. Once the move is valid, you move the piece. Then you check whether the king is under attack or not. If the king is under attack, we'll have to check whether there is a checkmate or not. If the checkmate happens, we have to say you win, right? We'll say you win. Otherwise, it will, if there is no checkmate, you go in the thinking mode, right? Now you think, what should I do next? So, and then after thinking, you make your move. And this whole thing will go in a loop until one of the person achieves the checkmate logic. So we can say everything runs in a loop until checkmate is say false. So we are running this in while checkmate equals to false. Everything, the function 1 happens. So let's call this as f1, f2, f3, f4, f5 and f6. We'll say while checkmate is false, f1, f2, f3, f4, right? So we are telling the game run f1, f2, f3, f4, f5, f6 while the checkmate is false. That means we are in an infinite loop until one person reaches checkmate and the checkmate becomes true. Whatever turn is at that time, that person is the winner. So in while we are breaking down our code in different function, one function to move the piece, one function to check the move, one function to check the checkmate logic, one function to make the thinking part, we are dividing our code into pieces that we have to manage. So next time when we run the code and if there is, say, if there is a logical error or if we have to do some change in the thinking function, then I know all my other functions do not need any edit. They're all good. I can only focus and I can only debug my thinking function, or I can only debug my check move function. So because my code is divided into different pieces, I can go and focus my attention piece by piece to solve the problem, right? It's kind of divide and conquer, dividing and winning the programming game, right? So that is called modularity. It helps us break our code into manageable sections. Again, this is we touched upon. It makes our debugging easier. So if there is a error in one of the function, I don't have to worry about other pieces of the code. My other functions are good to go. So it makes us easy to spot the error. I can even comment one of my function and I can check the other functions. If they are like, if there is a problem in my function 1, I can comment my function 1 and then run everything else to make sure everything else is running. So it makes all those debugging easy. This is, we'll talk more about, like just by changing the parameters to functions, we can change the whole behavior of the function. So say when there is one parameter to the function does one thing. And if there is another parameter to the function, it does other thing. For example, in a chess game, we can create a function which takes an argument whether it is one player or two player. If it is one player, then the other move is done by AI. And if I input two as an argument to the function, then we allow the other player to do the move. The AI goes silent. Now there are two real players making the move. So it's the same function that does the move, but in case of one, it does the move using an AI, and in case of two, it does the move letting the user do it. So that's flexibility by using the parameters. Now this is very important, the collaboration. Often when you work in a company, you are working with a team. There are many developers on that team. Like there would be 4 or 5 different Python programmers. If 5 programmers are writing the same piece of code, it will make your life lot more messy if all of you go and edit the code. Then you will not know what other person is editing, what you are editing, right? So the idea is we divide the pieces of code into different functions, and we say you will write or you will take care of function f1, the other person will take care of the function f2, and the third person will take care of the function f3, and then we'll collate all the functions and we'll run the program. This way one person can work on the thinking logic or the thinking function, other person can work on the rest of the functions, right? So it enables collaboration without interfering too much with each other's work. The other very important aspect is the object oriented programming. Now, we will learn about object oriented programming not in this series, because this series is all about learning Python from a data analyst or a data scientist perspective. So, we will learn all the capabilities of Python such that it lets you do all the job in the capacity of a data scientist. But from a software development angle, there is a whole different paradigm of developing softwares. So one paradigm is using these constructs or the control flows like the conditional, sequential, and looping, and we can solve any problem using this, using the combination of control flow. But there is an alternative way of programming, and that's called object oriented programming. In the object oriented programming world, the blood and the flesh is functions, because everything there runs on the basis of function. Like every method of a class is nothing but a function. Now you can see why functions are so useful. They don't solve one two, but they solve more than five different important aspects. They help reduce repetition, help you organize your code in a modular approach, help you debug the code easily, make flexible decisions based on the arguments, which is also a big thing in the world of object oriented programming. And it enables collaboration because it can allow multiple people to run different things without interfering with each other. When we are writing function, this is what we have to note. So when we are defining, when we say def function and we write what will happen inside the function, this is called definition of the function. So this is defining the function. Now you know this is comment, this is not going to run, but this is for our understanding. This is called the definition of the functions, because we are telling the interpreter this is what the function will do, but it doesn't do anything. It's just telling this is what you can do. When we call the function here, this is called a function call, because here I'm actually telling the computer to do everything that is written inside cube for the value of 2. Here I'm telling this is another call, this is another call, and this is one more call, right? So every time you call the function by its name, basically what interpreter is doing is it's saving your function in a piece of memory, just like we saw variables are nothing but memory storage, where the address of that storage location is given to your variable, and every time you refer the variable, interpreter goes and picks the value that is stored in that address. It does the same thing for function. Whatever line of code you write, it stacks all those lines, puts in a memory location, takes the address of that memory location, and assigns it to the function name. Every time you call your function name, it goes to the memory location of that function and figures out what are all the lines written there, and it executes those lines. That's what it does. So you have seen the queue function. Now let's make it little bit more powerful. So rather than queue, now let's make a very generic function where we are going to take two inputs from the user. One, the number or the base, and second, we will take the exponent. So rather than cube, if you put 4, we will raise that number to the power 4. If you enter the other number as 5, we will raise that number to the power 5. So we are trying to write a function that takes a base and that takes an exponent and prints the result, that is base power exponent. So we write here def, which defines the function. Let's call the function as power, and we give two arguments to the power function. One is the base, other is the exponent. And now semicolon. Now we say print f, and we say base. Here we have to write the exponent is base. So one asterisk is for multiplication, double asterisk is for exponent. We say base exponent. Right? This is it. This is my power function. Now I can call this power function. Let's call it for power 2 to the power 4. And next time we call it power 5 to the power 4. So let's see what's the output. 2 to the power 4 is 16 because 2 times 2 is 4, times 2 is 8, times 2 is 16. Same thing. 5 times 5 is 25, times 5 is 125, times 5 is 625. So you see, and this we can do for any number. We can do 2 to the power 10, which should be 1024. Power 2, 10. Yeah, see, 1024. So now we wrote a very generic function where we are giving two arguments and the function raises one number to the power of other number. Now let's also understand, what if I switch. I wanted 2 to the power 10, so I have to call the function as 210. What if I called function as power 10 comma 2? This will give me 100 because now it's trying to raise 10 to the power 2, right? So 10 raised to the power 2 is 100. So by default, whatever first number we are passing is the base, and the second number that we are passing is the exponent. Now this is called positional parameters because which number goes in what parameter is defined by the position. Now, if I don't want to take care of the position, I can pass it as a named parameter. For example, I can pass here power. Say I will pass 10 first, but I will tell computer like 10 is not the base, 10 is the exponent. So I can say exp is equals to 10 and then base is equals to 2. So even though the position is switched because the first number goes in base, the second number goes in exponent, I have switched, but still because I am using the name, it will give me the same result. It gives me 2 raised to the power 10 because I am telling the exponent is 10. So this is named parameter. So you can pass the parameter either using positions. If you don't give any name, the parameters will be passed according to their position. And if you don't want to take care of the positions, then you pass the parameter as named parameter. This is the difference between positional parameters and named parameters. Now, sometimes you have different number of parameters, right? For example, let's say I can pass any number of argument. If I pass 3 numbers, then you add 3 numbers. If I pass 5 numbers, you add 5 numbers. So it does not matter how many arguments I give, right? You just add all the arguments I give. So for that there is a special way. Let's create this new file that's called asterisk args. So what we can do here is we can say def my functions can be add, and then I can have here asterisk args. I can define this function as print sum of all, and then again let's call this 5 comma 4 comma 3. So that should be 12. Okay. Now here if I just give 2 comma 3, it will still add all the numbers. It sums all the arguments. This is the example of using custom. So most of your functions like sum, main, max, they are arg functions. You can give a variable number of parameters. So we learned functions, their use, parameters, positional parameter, named parameter, and any number of arguments. Now, till now, we have been printing the value of the function. We were not returning the value of the function. So what I can do is, rather than printing here, we can even return this number. We can say return base to the power exp. Now what this function does is, rather than printing inside whenever the function is called, rather than printing, it itself will behave like a function that you can use in evaluations, because it can take value and it can return value. For example, now my power 24 is returning, my power 24 will return, let's say I'm saying x is equals to 2 to the power 4. So whatever is the value of 2 to the power 4, it will put inside x. Now I can print x. Okay, see, x is 16. And then I can do same operation in the same. I can even say 10. So this should become 26. See, so this is now most of the basic structure of functions. Now we have mastered. We know we can write a function using the def keyword. Functions can take parameters. Parameters are optional. You can have named parameters, you can have positional parameter, you can even have a default parameter, and then your function can return a value. Now let's learn the other important concept about the scope of the variables. Let's understand what the scope means. So for example, when you're writing a long program, you can create a variable outside a function, and then you can have a same variable name inside the function. And then what would happen if you try to call the variable that was inside the function? Let's see how all these things relate. For example, I take a variable x and I say x is 10 to begin with, and then I say def custom function, and then I'm not taking any argument in custom function, but rather what I'm doing is I am creating a variable here, y is 15, and I'm trying to print here, print y is, I'm saying here y is y, and let's see if I want to print x here. Print, can I print x here? What do you think? I have x at the top. Can I print x here? Let's say I print this thing. This is called outside the function. Okay, so I say x is 10. I print x in the beginning is x, and then I'm defining a custom function. Inside the function, I'm making a variable y is 15. I'm printing y is y. I'm trying to see if I can get the value of x here. Now that's a question for you. What do you think that this will print? Then I modify the value of x. I say x is equals to 20. Now I try to print again. I say print new value of x inside the function is x, right? Then this is it. I want to end my function here. I go outside the function. Now I have defined the function. Nothing happens unless we call the function. So let's call the function here, custom func. And now after calling the function, let's print again x and y. Okay, I know the output, but let's see if you can guess what will happen. If I run this program, what am I going to see? Obviously, the first line will print. In the beginning, x is 10. This is what it will print. Then it will print y is 15. What will happen here at this line? What do you think? In my opinion, it will give an error. It will say x is not defined. And when I make x is 20, it will print the value of x is 20. It will say the new value of x inside the function is 20. That is what it will print when we call the function. Now after the function has finished running, when we say y outside the function is y, again this will give an error. Again, because we are using an id, you can say it's already saying y is not defined, right? So we will get an error here. And then if we resolve this error, when we say print x outside the function is what? Will it give the value 10 or will it give the value 20? What do you think? Now, these things may look overwhelming. I would say go ahead and see the video one more time, because these things are important. Because when you are writing big programs, the same variable may appear at different places, but you need to know what it will do. If we fix the error here, which we are going to get, and then if we fix the error here, outside the function x will again be 10. It won't be 20. Let's see. So x in the beginning is 10. Definitely this line got printed. Y is 15. This line got printed. But then we got an error. We say x is not defined, right? So for now, let's comment this line. So I'm going to comment this line. And then let's run it again. Because that's what we knew. That's what is going to happen. Okay. Now we got in the beginning x is 10, y is 15. Okay. Then we say this got printed. Now this obviously is not there. Now we said x is 20 and it's printing the new value of x inside the function is 20. It does print the new value of x inside the function is 20. Now because the function has ended here, y is no longer available. So think in this way. Every time the function is called, all the variables that are inside the function are in the environment of the function. They were available only at the time when the function was running. Once the function has finished, like it executed, all those variables disappear. That's why we are getting an error, y is not defined. Now let's comment even this line. Let's comment this line. Now let's run it after commenting that line. Now you see the magic. X in the beginning is 10, this line here. Y here is 15 because the custom function ran, and this line called y is 15 that printed because of that function call. And this line also printed the new value of x inside the function is 20. So these two lines are getting printed because of the function call. Now when the function call is done and we print x outside the function is 10, our original value of 10. So what does it mean? It means when the function is running, when the function is getting called, and when it runs in a memory with its own set of variables. If the function has the same name of variable as your main program, those variables are separate. That's called the local scope. Their scope is only until the time when the function is executing in the memory. So the function will access its own set of variables. You can manipulate those values. You can return any of the value from that calculation. But once function is out of the memory, once the function is done running, all the variables that were created as a part of that function run disappears. You cannot access them. And if there was even a variable with the same name inside the function as the outside variable is different. This is a global scope. When you run the main code, you will always access the outside variable value. You cannot get the functions, you cannot get the variable that were created inside the function, right? So think of it as a function is an independent unit that runs in the memory. You can say, okay, makes sense. This is intuitive, not big deal. What if I want to access my variable in the main inside the function? Right now you are seeing when we wrote here x is x, it was giving an error, right? So here I can type to access any of your main variable inside the function and to use them as the same value as the outside variable, you need to use the word global. So we can say here global x, because x is defined outside. Here we can say global x. So remember last time the inside value of x was different than the outside value of x. Now this time what will happen if we run this code? In starting we'll get the value x in the beginning is 10. We will get the value of y as 15. We'll say the new value of x is 20. But now because we have told to treat the global x, it's changing the value of the global x. So when you are outside the function, you will get the value 20. You will not get the value 10 like last time. See, x in the beginning is 10, y is 15. The new value of x inside the function is 20. And x outside the function is 20. It is no longer 10. You found a way how you can manipulate the global variable inside the function using the keyword global. Now, it's useful in many cases, but in most of the cases, it will become problematic. Why? In programming, you get logical error more often than syntax error. So in the beginning, when you are learning a programming language, you will get syntax error because you are just trying to understand all the keywords, how to use them. So in the beginning, you will get a lot of syntax error. But once you master programming, you know all the keywords, you know the rule of the language, you won't get a lot of syntax errors. What you will get is the logical errors because you want to do something, but because you haven't enough practiced, you think this way of coding is accurate, but then the result you get, even if the code runs without error, is very different than what you wanted, right? So that's the logical error. So most often programmers nightmare are the logical errors because they are very difficult to debug. You don't know. For syntax error, the interpreter tells you on this line, on this place there is an error, but for logical error you have to go and figure it on yourself where what might be happening different than what you wanted. So in that scenario, because your nightmare is logical error, if you start using global keyword and if you start changing the main variables or your outside or your global variables inside functions, it will be very very challenging to know which function is changing what value. And in real life, any application that you work on will easily have more than 20-30 functions easily. If you are working on a big piece of code, it may even have hundreds of functions. And if you are part of a software development team and that team is working on a product, you may even have hundreds of functions. So if the functions start changing global values inside functions using global statement, it will be very very difficult to know which function changed the value where. Even though it's an ability you can do it, it's not advisable. Most of the time we want to treat function as an independent piece of code. We let them have their own copy of variables, values that we think are necessary to run that code. We pass it using parameters, and once the function has done what it is supposed to do, it returns all the value to you, either in form of a return value like we saw in the power function, or you can even return a list. And we will learn what a list is, we will learn what a dictionary is. A function can return list, it can return dictionary, it can return anything you want, right? In the worst case scenario, you can create a global variable and you can make functions change those global variables as a desired outcome. You can do that. Technically, it's all possible, but not advisable because that's very dangerous route to take. And if you run into any logical error, it will be very difficult to debug them. So you at least know all the possibilities and capabilities of function, arguments, and everything, right? So mostly we have covered all the aspects of function. We'll just touch one more interesting thing that is very Python specific. And that is, in Python, we have one-liner function or even called as anonymous functions. So let's create a new file. So anonymous functions are like something where I can create very quickly. I can say x is lambda, because anonymous functions are always called lambda because you are not using def. So interpreter has to know some way like this is a function, and lambda lets it know it's a function. And because we are not using def, we are not even using a function name. So it's all anonymous. So after lambda, you just tell what will be your input variable, right? So I can say my input is a, and my output is a square. Okay, so I can say a times a, right? Then I can say, okay, so I said x is lambda a times a. Now I can call, if I just print x2, it will print me 4. Okay, easy. Here I can do anything. I can even take two arguments. I can say y is lambda a comma b, and return would be a plus b. Or let's do it a power function. It will be a to the power b, right? Like the power function we created. This is similar. I can do print y 3 comma 4. So this will be 3 to the power 4, which should be 81. Okay, 3 comma 20. So this is nothing but the whole function that we wrote here, the power function, like the def power base exponent. All it is doing is it's defining it very succinctly. Now lambda are very powerful when you want to do quick things many times. Like often we use it with list comprehensions, or we use it with other functions like map, sort, or filter. We'll talk more about them. But just remember, like, it's a special scenario. Lambda are nothing but functions. It's returning the value in y, and what it is returning is what is followed by this semicolon. It's taking anything before semicolon as an input, and it's returning anything that's after the semicolon as output. And then you can use this y by calling all those arguments. So the limitation of lambda is they can only have one liner here. You cannot write multiple lines here. After this semicolon, you cannot write two or three things. You can do multiple evaluations, but still you can return only one statement. So that's the limitation of lambda. So that's why they are also called as anonymous functions. Very easy, very quick to write. We use them a lot with map, sort, and filter. So friends, hope you enjoyed this video, and if you have watched so far, please like and subscribe to the channel. Share this video with all your friends who want to learn Python and master programming. Thank you so much for watching this video till the end, and I hope you learned something new today. Write in the comment what extra thing you would like to learn in context of functions in Python. So I'll see you in the next video. Until then, happy learning.